So in the last lesson, we talked about how to solve polynomial inequalities. This lesson, we're going to extend it so that you're going to actually write the inequality from some given information and then solve the information, generally using technology. So I'll probably pop up Desmos at some point to figure this out. So we're going to start with a real basic problem that just talks about something called revenue. So let's start with the example. And I'm going to annotate as I go. So the Jacobson brothers own and operate their own ghost tour business. They take tour groups around the bus, around the town, most notorious haunted spots. Okay. They charge $50 per tour. They book 100 tours at that price. Now they're considering decreasing the price per tour because they think that will help them book more tours. So they estimate they will gain 10 tours for every $1 decrease. Okay. So first thing is, what's revenue? In the case of this problem, revenue is going to be the number of tours times the cost per tour. Okay, so if we put this into what's going on right now. So right now, this is the current. All right, so right now they charge, they book 100 tours and they charge $50 per tour. So their revenue would be an even $5,000. Okay, that's the simplicity of the very beginning part. They think that they can make this be more money. So here's the thing. For every, so this is the $100 that, or the 100 tours that they currently have and the $50 price. Well, let's say they decrease this price by $1. So -1. And they think that they're going to gain 10 tours. So plus 10. All right. So this is going to turn into 110 times, let me fit that time sign in there, times 49. Kind of squished that in there. All right. Let me go ahead and pop up Desmos here, just because I'm going to use it as the calculator function. So what is 110 times 49? Well, that turned their profit, or their revenue, sorry, let me get the right term here, their revenue increased. So it went from 5,000 to 5,390. That's not too bad, all right? So if we keep doing this, let's say we do it again, and this time I'm going to make it slightly smaller here. All right, so there's the original, right? 100 tours, $50 per tour. Now, in this first one in blue, I subtracted 1, which means I gained 10 customers. Well, let's say I subtract $2. So for every $1 decrease, they're gaining 10 tours. So that's a $2 decrease would mean that they're going to gain 20 tours. So that would be 120 times 48. So let's see what that is in the calculator. Now let me go ahead and drop down to another line here. 120 times 48. All right, so now their profits are 5,760. So this actually makes sense for them. If they can, drop their price, they're actually gaining enough customers to make up the difference. All right, so if we did this one more time, let's say we do, so this would be, hold on, this was -$1, -$2. Let's go -3. Just see, keep going in the same order. So there's 100. So 50 minus 3, well, if we subtract $3, we're going to be gaining 30 tours. So that's going to be 130 times 47. So 100, whoops, drop down to another row again, 130 times 47. So now their profits have gone up 6,110. So that's pretty significant. Okay. So for us, we're going to let X represent the number of $1 decreases. Okay. All right. And I think I just spelled, no, I spelled decreases right. Okay. Write the function R of X of the revenue in terms of X. All right. So here's how it's going to work. R of X is going to equal, well, this is where we're going to do 100. And our original number was 50 here. Now, for each of these, we don't know how many of these X changes we're going to make. So we're just going to say we're going to subtract 1 times X. So minus 1X. The 1 is because we're decreasing $1. The X is because we don't know how many times we're going to do it. For each of these $1 decreases, the number of people taking the tour, the number of tours that we do, is going to increase by 10x. So if we just did $1 decrease, we increase by 10. If we do 2 $1 decreases, we increase by 20, keep going up, we don't know, okay? So find the maximum/minimum value, describe what it means in the context. So here's where the technology is going to come in. We're going to put this expression into Desmos. I'm going to make Desmos do my work for me. So what I'm going to do is I'm going to cancel out all of these equations that I had in there and literally type in as it's written. You do not need to multiply this out at all. All right, so 50 minus 1x. Just make sure you get all the pieces in the right places. All right. Now I can sort of see there's a little graph up here. So I'm going to go ahead and close this part down and zoom so I can see a little bit better what's going on this picture here. All right. So basically what I'm doing is just kind of squishing and making Desmos get into a graph that I can actually see almost all of it, or at least the important parts for myself. Okay, so first things first, this is a concave down parabola, which means that we are absolutely talking about a maximum value. Okay, so the maximum. Find the maximum value. So remember to do this in Desmos, just tap on the curve anywhere. It'll darken and it will also create these little gray dots that are key pieces of information. So we're going to find the tallest one here, the highest one. So the maximum is 29,000. So describe what it means in context. Well, X means the number of changes. So the brothers should make 20 $1 decreases to the cost of the tour. Let's actually write the right thing. Cost of the tour. And their revenue, I think I spelled that all right. Revenue will increase, increase to $9,000. Okay, so that's the kind of idea of what's going on with this point. X represents the number of changes, so they need to make 20 $1 changes, and this represents their revenue. That's the f of x, or in this case, r of x value. So what should the Jacobson brothers charge per tour to make the highest revenue? Well, this was the cost of the tour. So whatever 50 minus 1 times 20 is, so what is that? 50 minus 20 is, they should charge $30. Okay. And then part D is how many tours maximize the revenue. Well, this is the number of tours right here. And if you want to make a note of that, so this was number of tours, and this is the cost per tour. You can absolutely do those things to make note of it for yourself. So how many tours would maximize the revenue? Well, we're going to take 100 plus 10 times x, and in this case, x is 20. So 100 plus 200, they should maximize with 300 tours. All right. So that's the idea behind this very first example. It's a pretty basic one in terms of revenue. I'm going to keep going into problem number 2, and we're going to see if we can't use some of the same idea in that problem. All right, so sliding on down. All right, Glen High School Student Council is hosting a dance to raise money for Panda Bears. Go Panda Bears. All right, so let's start getting some information here. The dance is going to cost $2,250. Current ticket price of $10. They will have 180 people attend. Okay, but that's not enough to cover the cost of the dance. So they estimate for every 25-cent decrease in ticket price, 15 more people will attend. Okay, so for this problem, X is going to represent the, let's try this again, represent each 25-cent decrease. Okay. Write an equation that will represent the profit the dance makes. Now, one thing you need to know is what does it mean for profit? So up at the top, I'm going to make a little note to myself. Profit is the revenue minus any costs. Now, in this case, revenue would be the tickets. So the cost of the tickets. So cost of tickets times the number of people. And then we have a fixed cost of that 2,200. So if we talk about writing an equation, so let's call this P of X, right, profit. The revenue here, well, we're going to talk about the original cost of the ticket is $10. The original amount of money, amount of people showing up was 185. And the total cost of the dance is 2,250. Now, they estimate that for every 25-cent decrease, so 0.25, and we don't know how many of these we're going to make, so let's go ahead and tack an X on, that there are going to be 15 more people. So we're decreasing the cost and we're increasing the people. So plus 15x. So if we change the cost 3 times, we would take the number 15 times 3, because for each of those price changes, 15 more people are showing up. So this is the profit. All right, that's the equation that represents the profit. And inequality to represent the dance making a profit, that's a little different, but not too much. Basically, for the dance to make a profit, we want this equation, this part of the expression, to be greater than 0. All right, so 10 minus 0.25x, 185 plus 15x, and I'm not multiplying any of that out, don't need to. Minus 225 is going to be greater than 0. Okay, so what we're going to do, I'm going to go back to Desmos, and I'm going to put this mess in so we can figure out the maximization. All right, so let me go ahead and clear out what I had in there. All right, 10 minus 0.25x, and then 185 plus 15x minus 220, no, I keep saying it wrong, but 2250. Okay, so that's the equation. Now, right now, it looks like it's really difficult to find it, but this little itty-bitty part of the curve is where we're over on the x-axis. So I'm going to go ahead and zoom out just a little bit here. There we go. Okay. So this is our curve here. We can see that we have to sell some tickets in order to even start making a profit. So again, I'm going to tap on the curve and get my maximum value. Now this is where it's going to get a little bit weird. X has to represent the number of changes. So that means that X has to be a whole number. You either are going to make a change or you're not going to make a change. This 0.83 whatever doesn't work for us. So what I want you to do is take this X value, this 13.833, and round it. Round appropriately. So 0.833 would round up. All right. So we're going to say that X is equal to 14. Okay. And now when it says determine the price of the ticket that will maximize the profit. Well, right here is the price portion. It was 10 minus 0.25x. So 10 minus 0.25, and in our case, x is 14. So that means that the school should make 14 25-cent decreases. Let me get the right numbers in the right places here. And that's a 14. So they should charge $6.50 per ticket. Okay. How many people will need to buy tickets to maximize the profit? Well, this is the number of ticket change or number of changes that should be made. So apply that to the people part of your equation. So 185 plus 15 times 14. This is where it's helpful to just leave Desmos up, or if you have your own calculator, use that. So 15 times 14. So 395 people would need to buy the tickets to maximize the profit. What is the maximum profit? Well, we're going to take the number of people, so 395, times the ticket price that they just paid, minus the cost for the dance. So 395 times 6.5 minus 2,250. All right, so $317.50 is the profit. All right, that's all going to the Panda Bears. Yay. All right, what is the lowest ticket price they could charge and still make a profit of at least 200? Okay, now we know this is possible because they can make a profit of 300 and change. So making a profit of 200 is absolutely doable. The way I'm going to figure this out is, again, making Desmos do my work for me. I'm going to make a horizontal line at 200. So to make a horizontal line, we're going to do y equals 200. Okay. So right here and right here, so somewhere up here is where we're making this profit of 200. So these are the number of changes. This is our price. Basically, our price is decreasing as the changes go up. So right over here, I'm going to tap this, and I have this dark gray point. And now I want to figure out, I want to round this because I'm either going to make 19 changes or I'm going to make 20 changes. And I'm going to guess that it's probably going to be 19 changes. But let's see what happens there. So x is either going to equal 19 or x is going to equal 20. I'm not sure. I think 20 is going to make the profit go too low, but that's where I want to just do a quick check. So if I do x is equal to 19, so that's going to be 10 minus 0.25 times 19 times, and I'm running out of space here, so hold on one second. Let me delete this out and make it go the other direction. Okay, so if x equals 19, we're going to do 10 minus 0.25 times 19 and 185 plus 15 times 19. And then take that answer, subtract 2,250, and let's see what we get. So into Desmos I go. Lots of numbers to put in. 25 times 19, 185 plus 15 times 19, and then minus 220. Whoops, I said the wrong thing. There we go. Okay, so a X value of 19 gets me a profit of $217.50. So that is absolutely, that's okay for having that profit, which would give me an actual ticket price. Remember, this part right here is the ticket price. So let's actually figure out what that is. So 10 minus 0.25 times 19. Whoops, lost the times. All right, so that would be a ticket price of $5.25. But I want to see if maybe I can push it just a little bit further and say X is equal to 20. Can I make 20 25-cent changes? So I'm going to do this entire equation all over again. But instead of having 19, I'm going to use 20. And that's going to go right into Desmos. And again, I'm kind of feeling like this is going to be the wrong answer. I think it's going to push it so the profits are not at least 200, but I want to double check. And basically, whatever your X value is when you check the maximum, or in this case, that intersection point, go above and below it one value and see what you get. Let's see, minus. Yep. All right. So what I did is I put this expression in the calculator and I got a profit of only $175. Since we're trying to make a profit of at least 200, we know this isn't going to work. So that is not a possibility. What's the lowest ticket price? $5.25. All right, so I'm going to close this video for right now. I will make a separate video for the other two examples. If you have any questions or concerns about any of the information in this video or the other one, please let me know so I can help you understand it.